All right, epoxides. Epoxides react in two ways, in two conditions: acidic and basic conditions. Uh, and so in H2SO4, that's really considered acidic. Right? That's a strong acid, reactive acid, as I like to call them. So there's H plus in the system. So the first thing that's going to happen actually is something similar we've been thinking about is actually protonation. Now the question is not asking you to do this, but hey, we're going to do it. Um, and then of course makes the carbons 1 and 2 more reactive. And the question then is, oh, wait a second. And you know, a lot of times I would have put this on top, and this is a solvent, so I put that on the bottom. They kind of have things mixed around here, in my opinion. Um, the question is, which carbon is actually going to be the best electrophile in acidic conditions? So in acidic conditions, it's all about the most substituted. So think about like carbocations, even though there are no carbocations here. But so carbon 1 is the most substituted, so that's actually the one that's going to react. That SN2 type trans addition. Let's bring you the OH there. And H plus is actually a catalyst here, sulfuric acid is. And so the last step, of course, is deprotonation, and that gets us to the product. And they're not worried about stereochemistry here. Of course, if you did care, the OH and this would be, of course, trans to each other. Carbon 1, carbon 2, carbon 1, carbon 2. So in acidic conditions with epoxides, it's all about the most substituted carbon. That's the one that gets reacted with in a trans fashion. If it was basic conditions, then it's all about sterics. So basic conditions could look like CH3O minus, right? So that you see that negative charge. Now in basic conditions, it's going to go for carbon 2. So you get a different regioisomer, you get different regiochemistry. You're picking a different region of the epoxide. Acidic, most substituted; basic, sterics, less substituted.